Alright, Chapter 3, Temperature. I know what you're thinking. Another boring chapter. Yes. Sorry. Some of it's kind of interesting, but yes, sorry. Okay, so on here, you can see this is Fahrenheit, right, in the scale, always, 40 to 100. And oddly enough, the year is a little bit weird. September, October, November, December, January is up here, and then all the way to August. Okay, so this is the average low down here, and this red line is the average high. And so you can see how it varies, right, throughout the year. You can also see that the warmer months are over here. Now this one is for St. Pete. It's a St. Pete temperature. Okay, so the warmer months are August, right? July, August. Summer months kind of make sense. And then the colder months are January, maybe February, right? We're kind of warming up in February there. Okay, there's a whole bunch of calculations that you can do with data, just because people like to write down, even though they're online and you can download all this, but there you go. The daily mean. The mean just means average, right? That's the fancy math word for average. So what you do is you take all of the 24 readings and you average them out, right? You take a reading every hour for 24 hours and then you average them out. The daily temperature range is, remember, you still have all those 24-hour temperatures, right? So you take the highest one and the lowest one and you subtract. Range ahead. Had a math teacher described range as Mariah Carey. And I was like, huh? But she can go really low when she sings, and she can go really high when she sings. And so the difference between that low and the high, that is her range, right? That's her musical range. Same thing with temperatures, right? The really low one and the really high one, you subtract those and you get your range. Monthly mean. Right, so daily was the 24 hours, every hour you go take a reading. Well, the monthly is you take all of those daily ones, right, and you average that. And then the annual mean is you take all of the monthly means and you average that. And then the annual temperature range is actually, again, the highest and the lowest, but of the monthly means, right? So the daily temperature range, high and low of hourly, annual temperature range, high and low of monthly. Yeah. So for the mean, this is how you do it. You add up all of the hourly temperatures and divide by 24. Why 24? Because hourly temperatures, right, once every hour, there's 24 hours in a day, so you can take all 24, add, and then divide by 24. The temperature range, again, the difference between the high and the low. So take the high, subtract the low, and there is your range. Monthly mean. This one has a little bit of flat to it, okay? You take all of your daily means and you divide by however many that you have. So some months, February, have 28 or 29 days. Some months have 30 or 31 days, right? So however many numbers or days that you have, you add them all together, you divide by that number of days. Annual mean, you take all of those monthly means and divide by 12. I can say 12 because there's only 12 months in a year, right? So all 12 monthly means, add them all up, divide by 12. And then the temperature range, the annual temperature range, take the highest and the lowest monthly mean, subtract, right? High minus the low, there's your temperature range. Okay, now, just so that you can get this again, we'll watch this lovely YouTube video. Because to me, nothing works better than a song.
So, we want to learn about median and mode and mean and range as well. It's the different ways of finding averages from a set of data, from numbers. So, yeah, pay attention.
Hey, diddle diddle,
the median's the middle. You add, then divide for the mean. The mode is the one that you see the most, and the range is the difference between. Hey diddle diddle, the median's the middle. You add, then divide for the mean. The mode is the one that you see the most, and the range is the difference between. Hey diddle diddle, the median's the middle. You add, then divide for the mean. The mode is the one that you see the most, and the range is the difference between. Hey diddle diddle, the median's the middle. You add, then divide for the mean. The mode is the one that you see the most, and the range is the difference between. Hey diddle diddle.
Okay, isotherms. Isotherms, they're basically lines on a map. That's what an isotherm is. But it's a line on a map that represents temperature. Okay? So scientifically, you look at this. Most people look at this nice colorful one at the bottom, right? Where you can see, okay, all this peachy, orangey thing is 80, yellow is 70s, there's 60s, greens 50s, blue, darker blue, purples, right? And you can know instantaneously that Florida is 80 degrees. Okay. Here is the exact same thing. They just didn't color code it for you. Okay, so this is what the scientists would look at. And you're like, okay, well, what does this mean? Well, I mean, you can see a few things. Miami's 85, right? There's the 80 line. It's the exact same line here, except they color in anywhere that is 80. And here they're just like, okay, here's 80 all the way along here. You kind of go up, there's a little jump, comes up here, goes back down. So anything in this section is going to be 81, 82, 89, somewhere in that 80s, okay? And how do we know it's not 90? Because, well, here's the 90 line. Now, usually these things are 5 or 10 degrees. You can make them any degree that you want, but it kind of depends on how big your map is, right? This is a map of the entire United States, or continental United States, and so they're going by tens, right? If you're doing maybe just our area, you might want to do 5 degrees. You could do 2 degrees. You don't really want to go down to 1. You could. There's no rule against that, but that would just be really, really messy. Right? So that's why we kind of use nice roundish numbers. Okay. And the fun thing about isotherms is that isotherms, you cannot have them cross. Like if you look right here, they are very, very, very close right here. What's that, Colorado? They are very, very close right here, but they are not meeting. Oh wait, Colorado's there. Sorry, Utah. They're not meeting. You can't touch, okay? Because if you touch or cross, then the scientists get all confused. Because this means, this line here, this top one, means that it is 40 degrees. And this bottom one means that it's 50 degrees. So if you were to cross them, then you're saying wherever they cross or touch, it is both 50 degrees outside and 40 degrees outside. Now, I know sometimes when you're in the shade, you're like, oh, it dropped like 10 degrees, right? But yeah, no, it's either going to be 50 degrees outside or 40 degrees outside. It's not going to be 50 degrees and 40 degrees at the exact same spot. That can't happen, right? So you can get really, really close. Here's another one that's kind of really close. You can do all these fancy little jets out here and wiggles, but you cannot cross them. Okay? You can't cross, can't touch. Now here's the fancy word, temperature gradient. Right? And here's your fancy math thing, temperature divided by distance. Okay? What this means is there a really big change in temperature or a really small change in temperature, right? Like if you were driving from Miami to Louisville, you would be 80s, 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 way to Tampa, 80s, 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 cross into a whole different state, 80s, 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 cross into another state, 70s, 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 cross into another state, 70s, and then you'd cross and you'd get 60s, right? So you have a long way to go. Like that's a good day's drive, right? A long way to go to change 20 degrees. But if you're over here in Tucson and you want to go to, what's that, Ely? If you're from there, I apologize. Right. Well, Tucson, you're at 70. So you go, oh, okay, now we're at 60. Okay. Oh, now we're at 50. Okay. Now we're at 40s. Oh, wait, we're back to 50s. Oh, wait, nope, we're back to 40s. Oh, and there we go. We made it, right? So, not even the same distance. I would argue that's less of a distance than that. And you've changed 30 degrees, 35 degrees. Right, so temperature versus distance. Short way, big change. Long way, not as big a change. Right, so that's temperature gradient.